All right, our next video lesson here, theoretical and experimental probability. So either get your note packet ready for this lesson or open up to the next spot in your notebook, write down this title and learning target. Our learning target being I can find and compare theoretical and experimental probabilities. Okay, so two vocab words here for you. The first one being theoretical probability. So we learned about just probability of simple events. So now we're learning about these specific types of probability. So theoretical probability is what should happen. Okay, so this is like the probability that we already learned about. So just thinking about something like a coin, theoretical probability is what should happen if you flipped the coin. Experimental probability, just like the word here has experiment, that means if we were to actually do an experiment of something, this is what did happen. Okay, so theoretical, in theory, what should happen? Experimental, in the experiment, what did happen? So make sure you have those written down. Okay, so we're going to go through the examples. Again, I want to see all of these examples in your notes when I look over them. Make sure you have the actual question written down so that when you look back, the answer makes sense and it's not just a random fraction, but you can actually see what the answer is referring to. So the first one, if a coin is flipped 10 times, theoretically, how many times should it land on heads? Well, if we think about flipping a coin, we know that there's a 50-50 chance, or a 1/2 probability that it's going to land on heads. So if we're flipping the coin 10 times, theoretically, half of the time it should land on heads, which would be 5 times. So the theoretical probability is 1/2. That's what should happen. But the question is asking how many times should it land on heads? Well, half of the time, half of 10 is 5. So 5 times it should land on heads. All right. But if the coin landed on heads 7 times, what is the experimental probability of the coin, or coin landing on heads? Experimental is what actually did happen in the experiment, and it's telling us that it landed on it 7 times out of the 10 flips. So that means it's got a 7 out of 10 experimental probability. Okay, some more questions here, kind of comparing the two parts. A dice is rolled 24 times. What is the theoretical probability of rolling a 5? The big part here, whenever it's asking about like what is the theoretical probability, this 24 times, in this case, it doesn't really matter because it's just asking us theoretically the probability of rolling a 5. Well, on a 5, that's 1 out of 6 outcomes. So the theoretical probability, 1 out of 6. If a 5 is rolled 8 times, what is the experimental probability of rolling a 5? So this is what actually happened when I did the experiment. Well, it's telling me here that it landed on that 8 times. So 8 out of the 24 times that we rolled it. And then we'll simplify this to be 1/3. So when I actually did the experiment, I rolled a 5 1/3 of the time. In the above experiment, what is the experimental probability of not rolling a 5? Well, if I rolled a 5 8 times, that means every other roll was not a 5. So I could take 24 and I could subtract off the 8, which would be 16. So that means 16 of the times it did not land on 5. So the probability, experimental probability, would be 16 out of 24. And now if I simplify that, I can divide them both by 8, which would be 2/3, which makes sense since this is 1/3 plus 2/3 equals a whole. So you could think about it that way too. If I spun this spinner 40 times, what is the theoretical, in theory, what should happen of landing on a 2? Well, the 2 is 1 out of 4 possible outcomes. So the theoretical probability, 1/4. Again, this 40 times doesn't really matter for this question. Now on the next one, if I landed on a 2 16 times, what is the experimental probability? Again, experimental probability is what did happen. And it's telling me that I rolled it 16 out of 40 times. And I should simplify that. I can divide them both by 4, which would be, actually I can divide them both by 8, which would be 2/5. So 2/5 of the time it landed on a 2. All right, next part here, the graph shows the results of an experiment in which a spinner with 3 equal sections is spun 60 times. Find the experimental probability of spinning red for this experiment. Okay, so if we look at it, okay, we can see the 3 different colors and how many rolls per color. And it's telling us that it was spun 60 times. If it didn't tell us that, we could also add up the numbers on here to figure out that it equals 60. And we want to know experimental probability, that's what did happen in the experiment. Well, it shows that we spun a red 24 times out of the 60. I can divide those both by 6. 24 divided by 6 is 4. 60 divided by 6 is 10. And then I can divide each of those by 2, which equals 2/5. So the experimental probability of landing on the red was 2/5. Next part, compare the experimental probability you found to the theoretical probability. Okay, well, theoretically, there's 3 outcomes, one of them being red. So the theoretical probability would be 1/3. And we got the experimental was 2/5. So we are trying to compare these fractions. Okay. This is equal to 2/6, and 2/5 and 2/6 are pretty close. So you could say, when you're comparing them, the experimental and theoretical were pretty close. Okay. Or let's say you had them that were super far apart. You could say that they were very far apart and they weren't close together and you didn't quite get as many as would be expected. But it looks like based on this experiment and what actually did happen, we got the probability pretty close to what we would be expecting to get. So it's just asking you to talk about the differences between them, if they're close to each other, if they're not. All right, predicting future events. So we're using what we found now to predict what will happen in the future. So a video streaming analyst examines last year's video genre selections of customers. Last year's selections are shown in the table. What is the probability that a person streamed a comedy genre? So we're actually looking at the information in here. So the comedy was 580. And in order to figure out the total, we're going to need to add all of those together. So I am going to go ahead and use my calculator, which you can use on this unit. 670 plus 580 plus 450 plus 300, which is 2,000. Let's see. Oops, 2,000. Okay. Okay, and then you could simplify that. We could divide it by 10, which would make it 58 out of 200. And then, let's see, I know they're both even, so we could divide them by 2 again. 58 divided by 2 is 29 over 100. Okay. Now, Sorry about that. Now, the next question says, suppose the analyst expects 5,000 customers this year. How many drama selections should be expected? Well, we had 450. We're looking at drama now. 450 out of the 2,000 we had up here. But now we want to know for out of 5,000 customers. Okay, and we're trying to figure out how many we would expect. Well, we just set up a proportion that we can now use. We can cross multiply in order to solve. So I multiply 450 times 5,000, which would be 2,000x equals, oops, I just used a calculator for this. Divide both sides by 2,000 to solve for x. Hold on, I gotta double check that. There we go. My division was off there for a second, so x equals 1,125. So that means that they should expect that many drama selections. Okay. So if they're asking you to figure out for the future, you can just set up a proportion for however many they're asking about and solve it that way. Okay, so a recap. This is the part that's super, super important for this lesson. Theoretical is what should happen. In theory, right, what happened? This is just kind of a fancier way of saying what we learned about with the probability of simple events. Experimental probability is what actually happened. So we did an experiment, and now we are figuring out what actually happened from that experiment. The higher the number of experiments, the closer that the theoretical and experimental will most likely be. So make sure you write that down. So what that's saying, if I flip a coin 5 times, my experimental probability might not be as close to my theoretical. If I flipped a coin 500 times, it will eventually start getting to the point where it gets closer and closer to the the theoretical probability, the more times you do it. Okay, so here's the questions that I want to see completed at the bottom of your notes. So you're going to pause here and actually try these ones on your own. Number 1, we're using that spinner again, and we're spinning it 12 times. What's the theoretical probability of landing on a 3? And then you're also looking and seeing what the experimental probability is. Number 2, flipping a coin 80 times, theoretically. So how many times should you land on tails? And then, which means the theoretical probability. So now it's actually asking for the probability. And then if it landed on tails 30 times, what's the experimental probability? So I want to see these at the bottom of your notes.